Hello, welcome to everyone in this video. This is day 15. Actually, we discussed the previous year of question IIT JAM. 14 lecture actually covered. Uh, and in this part, we want to discuss question which asked in 2015 from mechanics and general properties of matter. If you want to watch the total playlist or other lectures depending upon the previous year solution of IIT JAM of physics, you can go through the description box, link are given there, and different physics related video also available in this channel. So let's start today's discussion. So first question which says a mass m, this is a mass m lying a horizontal frictionless surface, this is a lineless horizontal frictionless surface, is connected with one end with the spring, this is connected with this spring, the other end is spring is connected with a wall, this is a wall connect with this wall as shown in this figure. At time t equal to 0, the mass is given an impulse. At the time 0, this gives its impulse. For that, this mass will move at this direction. So this is a mean position, and after that, this will oscillate like that. So at t equal to 0, this is at mean position. So at t equal to 0, this is a mean position. So the equation will be a sine omega t, because at t equal to 0, x must be 0, just like a pendulum. If you consider this is a pendulum, when you impulse at that position, you can see that at t equal to 0, x must be 0. So the equation will be x equal to a sine omega t, because at t equal to 0, this will be 0, and at some t, this will be maximum. So this is the similar to that one here also. So you can take this position with respect to time at a sine omega t. What about the velocity? Velocity is nothing but the time derivative of this position. So if you take this derivative, you will be get a omega cos omega t. A omega can be taken as b. So the position will be a sine omega t, and the velocity will be b cos omega t. So the answer will be option number A is the correct answer. I think clear. If there is any doubt, you must comment in the comment box. Next, a portion a proton from outer space is moving towards Earth with velocity 0.99 c as mentioned in Earth frame. So this is the velocity of the proton which measured with respect to Earth frame. A spaceship traveling parallel to the proton measures the proton velocity is like that. So with respect to spaceship, the proton velocity will be like that. The approximate velocity of the spaceship will be from the velocity addition theorem in the special theory of relativity. You know that is the speed relative velocity with respect to that one is v equal to u minus v 1 minus uv by c square. You know, if you consider this is non-relativistic, the velocity will be u minus v. Relative velocity will be u minus v. But in case of relativistic case, this velocity will be u minus v by 1 minus uv by c square. Just put this value. U is the speed of this proton with respect to rest frame. V is the speed of this uh, v is the speed of this with respect to that one. So after that, uh, actually the question is says the measuring velocity will be like that. The approximate velocity of the spaceship with respect to frame. So average velocity with respect to frame. So this will be u equals to 0.99 c, and in this will be the v, the velocity of this particle. So just calculating this one, you can easily find out this velocity 0.5 c. Okay, the calculation you can do this calculation very easy. Go to the next one. Next question say a satellite moves around the earth. The satellite moves around the earth with orbital radius r center at the earth. Okay. A second satellite moves in the elliptical orbit of the major axis 8r. The another one is major 8r axis moves with the earth, one is foci. If the former takes 1 day, that is the initial one take the first one is take 1 day to revolve completely, the later one takes. From the Kepler's third law, you can say this is the time period square is proportional to the radius cube. So from the given data, you can see at the first one the R1 equals to R, and second one is R2 equal to 8R, and the corresponding time T1 equals to 1 day and T2 equals to question I don't know, we need to find out this time period. So T2 by T1 whole square equal to R2 by R1 whole cube. So just taking T2 equals to T1 R2 by R1 whole to the power 3 by 2. So R2 equals to 8R and R1 equals to R. So finally we will get 8 to the power 3 by 2. So 8 root 8, root 8 means 4 into 2, so this is 2 root 2, 16 root 2. So you can see this is above the 16, and another one option is 21.6. Only one option is available, so this will be the answer. Go to the next one. Next question says, an observer is located on a horizontal circular tunnel which rotates about vertical axis passing through the center with a uniform angular speed. This is a uniform angular speed omega. A mass of 10 gram is sliding without friction or tunnel. Without friction, this our mass is moved. At any instant, the mass of distance it 8 centimeter from the axis. This is the distance is observed towards the center with speed. This is the speed v. The net force on the mass. Here actually, when a body is circulated motion on the earth, there are actually two force arises. One is Coriolis force and another one is the centrifugal force. Okay, so due to rotation of earth, you know there is another force arises. This is the Coriolis force due to the rotation of the earth, and the centrifugal force actually happening when the body is circularly rotating. Okay, so the Coriolis force will be minus 2m omega cross v, and the centrifugal force equal to m omega square r. This is tangential force and this is radial force. So if you find these two value, this 2m is 10 gram, you change this gram to kilogram, and then omega is 2 radian per second, this is not change, and the v is 6 centimeter per second, centimeter converted into meter. So you will be get this one. This is the Coriolis force. Centrifugal force m omega square r. This is the m 10 gram, 10 into the minus 3. Omega square, omega is 2 square into r. What is the value of r? R is 8 centimeter converted into meter. So you will be get this is the uh, centripetal force. So these two forces are perpendicular to each other. So net force will be root under fc square plus fc square. So if you just put this value, you will finally find out this force. So answer will be option number C. Go to the next one. Next question says 7 uniform discs. These are the 7 uniform discs. 1, 2, 3, 4, 5, 6, 7. Each of mass m and radius r are inscribed within a regular hexagon shown in this figure. The moment of inertia of this system of 7 discs about an axis passing through the central disc and perpendicular to the plane of the disc. So there is a central disc. You need to find out the center. You need to find out the moment of inertia about that axis which is passing through the central disc and perpendicular. I think clear. You the axis which we about find out. So with respect to this axis, the moment of inertia of this central disc will be half mr square, no problem. But in case of these outer disc, if you consider this one, the separation will be 2r. So the moment of inertia of this disc number 2 with respect to that axis which is passing through this center will be like that, half m square plus m into distance square. Okay, so this is the moment of inertia for that one. So these are the similar, so they are these 6 are multiply here. So if you calculating, this will answer will be obtained. Okay, I think clear. If there is any doubt, you must comment in the comment box. Go next question. Go to the next question. Next question says a particle of mass m moving in xy plane at any given time t, the position vector is given. This is the position vector. Which one of the following statement are true? You need to find out which one is the true. Okay. So the position vector given here, and any position vector can be written as xi cap plus yj cap. So if you consider this is as a x and this as a y, so just rearranging them, you will be get this one cos square omega t plus sin square omega t. So just yeah, this is one. So this is the equation of ellipse. So first one, that is the orbit of the particle is ellipse. This is the correct. Okay. Next, this velocity. Velocity is dr by dt. If you derivative with respect to t, you will be get that is minus omega a sin omega t, and here the omega b cos omega t. If you just find out the speed, that is the magnitude of the velocity, you will be get that one. And you can see here this a and b are the difference. So this cannot be cancelled out, and this is a function of t. So this is not a constant. So b is not correct. At any time t, the particle experiences force towards the origin. So you need to find out the force. For that you need to find out the acceleration. Acceleration is nothing but the derivative with the velocity of velocity with respect to time. So if you just derivative with respect to time of this velocity, you will be get that is the minus omega square a cos omega t, and this is minus omega square v sin omega t. If you common this omega square, you will be get this r vector. So you can see this is the momentum, that is the r vector, and the force will be nothing but the mass into acceleration. Okay, so force will be mass into acceleration. So the corresponding angular momentum, so the force is towards the origin, so you will be get that the force is towards the origin, and the angular momentum, you know, that is L vector equal to r cross p. Okay, so if you put this value, and p equal to mv, so m r cross v. So if you put this value of r is like that, and v equal to this one is the v, that is the this one is the v. So if you just put this value v, you will be get just cross product, taking the cross product with respect to this r, this is the r position vector, and this is the velocity v. So r cross r, sorry, r cross b. So I cross I is 0, I cross j is omega a omega t k, and this j cross I minus k. So finally will be get this one. So if there is 2, then this will be matches, but there is no 2 present here. So if there is a 2 arises here, then this will be matches, but here there is no 2. So option D is not correct. Okay, so option A and C is the correct of this question. Okay, go to the next question. I think there is a hang of my uh, laptop. Some problem arises here. I try to solve this problem. I don't know what to do. If I skip this one, but this does not work. Okay, I try to solve this thing, but this is not working here. So I give you the PDF within the description box of this of the lecture. You see this rest of this question answer, and if there is any doubt, you must comment in the comment box. Okay, so sorry for this inconvenience. I don't know what I can do at this moment. Just I want to say that I will be give you the PDF of this lecture in the description box. You can download this one and watch the solution of the rest one also. Okay, so thanks for listening. I will try in the next time with the proper manner. Okay, thank you.